Welcome to Compulsive DIY. Behind me is the project that I call Santana Coiler. It's my coil conversion Land Rover project that started, it's fair to say, before YouTube was popular, when I bought a 1980 Santana Series 3 Land Rover that for most of its life was a work truck on a coffee plantation in Costa Rica. So in 1980, it was made in Spain by the Santa Ana Motor Company, which was initially assembling Land Rover kits. But as British Leland got into trouble and had labor issues and other difficulties, the Santana company started improving it. And this particular vehicle had a number of improvements. But it had a hard life on the coffee farm. When it was built, it had that 65 horsepower naturally aspirated diesel that is impossible to drive on public roads today, and certainly you couldn't drive it at highway speeds. The reason I call it a coiler is because it's been converted to a coil spring suspension. You can see the top of a coil spring right here. So it's sitting on a modified chassis. It's this galvanized chassis you see back there. It's a chassis that accepts the axles and the suspension components from Land Rover Defender and Discovery. On top, it's going to be mostly Series 3, although currently we have firewall modifications that are being done. And putting these components onto the chassis, unfortunately, didn't end up on video. But I'm hoping to make some videos of the next steps. And the step today is the seat box. The seat box is aluminum, like most of this vehicle. And when they were originally made, the aluminum panels were connected through resistance spot welding. And I don't have a spot welder, so I will be using aircraft rivets, which I bought from an airplane supply house, and aircraft riveting methods to rebuild this seat box. The sides of the seat box take a great deal of beating because people hit their feet on them as they get in and out of these vehicles. The front of the seat box will have to be modified anyway. It's already partially modified to accept the newer transmission that I have in there. And the top of the seat box, in my case, is going to be converted to a single aluminum sheet. I will show you later, these seat boxes used to have tool boxes and then later on battery boxes, and tops of them consisted of 1 million pieces. But the top of the seat box is the bottom of the passenger compartment. So underneath is outside. So I think I'm going to have a more watertight and more aesthetically pleasing seat box if it has a single piece of metal on top. So let's get working on it. So here's the plan for this seat box restoration. In this freeze frame, I'm holding on to the seat box front. I'm actually holding on to it upside down. In the middle is the cutout for the transmission and the parking brake. On the part of the table that's closer to the camera, there is a pile of the pieces that I'm throwing away. They include stiffeners from the top that I will not be reusing at all, and also the seat box sides, the two parts that take a beating. And it is only a 3-sided box with top stiffeners, although I'm going to put on a solid top on it, as I'm going to show you just a little bit later. So I have the 2 new sides, and these are much needed replacement parts because people kick them as they get in and out of the vehicle. So before I begin actually working on the box, here's a brief introduction to how it's going to be done. This is a practice project clamped in a vise, just 2 pieces of scrap that were drilled, deburred, and countersunk. In the background is the vehicle and the brown skin that I riveted onto the old tub with these tools about a year ago. You can see the rows of the rivets. I had the same issue, so I didn't have a spot welder, so this is the rivet gun I used to modify that tub. These are sides from the Land Rover Defender that was shortened and then riveted onto the old tub. So this is the rivet set that strikes the manufactured head of the rivet as the rivet gun vibrates and goes back and forth, and that's the bucking bar that's held against the thin end of the rivet. And as this pounding takes place, the shop head is formed on the back of the rivet. And it's important to hold this tool correctly. If it's tilted like this, it will walk across and cause damage to the surface, these semicircular dents, which you don't want. So the challenge in being good at this is making sure you hold it perpendicular. However, they do make this clever swivel head that's a bit more forgiving. If you tilt a bit, you can get away with it. So pounding rivets is how the old front of the seat box is going to be attached to the new sides and the new top made out of a piece of the sheet metal. So I am getting ready to pound this rivet in. Here is the pounding action of the gun. The polished head goes over the factory head of the rivet, sometimes called finished head. That's the countersink head that was created at the factory. I place the bucking bar against the other side and start firing some bursts. The Cleco on top is holding things together temporarily. Cleco is a temporary blind holder which can be inserted from one side. When you squeeze the Cleco with pliers, it becomes thinner and longer, and then as the jaws of it pull back, they hold the material together. And here I'm about to check my shop head. That's my shop head that I just created by having it vibrate against the bucking bar. It should be more than 1.5 diameter of the rivet. It's a -4, so it doesn't fit through the -4 hole, so it's big enough. So it's not that beautiful, but it's adequate. But one does get better with practice. And so now these 2 pieces of aluminum are joined. And now if I took the Cleco out, they would stay together, and the Cleco could be replaced with another rivet. And so is the whole process sped up. This will have to be done hundreds of times on the box. Rivets get pounded, shop heads are formed, rivets are checked, although with experience you start getting a good sense as to whether it's done or not. And so the row that can hold 2 parts together is created. Eventually the Clecos, which are the temporary holders, they're called Clecos because they were invented by Cleveland Aircraft Tool Company, are removed because you now have your permanent holders in place. So first you have to assemble your whole assembly with Clecos, and then you remove them 1 or 2 at a time and replace them with permanent rivets. This one isn't big enough, it needs a little more pounding. There we go. So now the shop head is big enough, and this is strong enough. and we can put in a couple of the last ones. And that's how I'm going to put together this box in part 1, which you are watching now. I'm going to drill and temporarily pre-assemble everything with Clecos. In part 2, I'm going to cut out my single piece top, and everything will be drilled, match drilled, and countersunk. And then the rivet pounding will begin in part 2. So here is the theory behind this. This is a Series 3 parts catalog. And here is the seat box. It's composed of the two sides, the front panel. Only the front panel is going to be original on my rebuild, and I would have liked to replace it as well, but I can't locate one. One isn't available. So here is the Defender parts catalog, and you can see a similar design here with a million parts on top. But the rear seat box in what was called Defender 110, so the 4-door Defender, has a solid top. That's a single sheet of metal. So my plan is to make my front seat box like the rear seat box of the Defender 110. Because I don't have a spot welder, I will need to use different methods to attach aluminum panels to each other. And my plan is to use aircraft aluminum techniques, which I am learning from this book. It's a aircraft sheet metal book. Poole must have been the first owner because I got this used. Here is the chapter on riveting. I'm planning to use countersunk rivets of this type. In aviation, it's called the 426, which is shown here. It's got a 100-degree countersunk head, and I have countersinking equipment for it. There is a little bit of education on the rivet spacing, how far from the edge rivets should be, and how they should be driven. Thin airplane skins are dimpled. So a dimple die is used to create the depression in which the head of the rivet sits. Thicker ones, and my material would be considered pretty thick by airplane standards, a countersunk with what they call a machine countersink. I am using aircraft guidelines for strength in building this assembly, mostly for practice. So the layout for aircraft riveting work is done with a rivet spacer tool like this, and that's how you set the rivet pitch and evenly divide them on projects. So this rivet spacing gauge has a hole for the number 40 drill bit, and so here is the number 40 drill bit with its drill stop, and the drill stop is color coded silver, and so the Cleco, which is the blind holder that holds things together, here it is. So the Cleco that uses the hole made by the number 40 drill bit is silver, just like the drill stop on the number 40 drill bit, and of course it's operated with the Cleco pliers. And here's a video of me putting the box together with Clecos. These are actually copper colored Clecos because this was a fit after the final drilling. But the box went together and apart like this many times, of course. And here is the beginning of the chronological build. I'm not going to be jumping between the present and the future anymore. the box has been clamped together with those spring clamps for the first time, and I'm gearing up to drill the very first hole in this location. So I arbitrarily decided to start this process at this corner of the seat box. The rear will have to be clamped to final width in the vehicle anyway. But this front edge here is a nice place to start. The rivets will be 1/2 inch from the edge. They have to stop here because there is an underneath stiffener that will be behind there eventually. So this is roughly the location of the first rivet that I'm marking here. Center punch the first one. Going to Cleco the first one. Number 40 drill bit takes a silver Cleco. My last one should be somewhere in this vicinity, so we'll mark that. Got that center punched, let's drill. And at this point, I think I'm going to Cleco the rivet spacer in place. I need about 1 inch pitch. Something like this. Okay, Cleco it on the bottom. Definitely holding it together. Well, it'd be nice to get a little tighter before the riveting begins down below. That could be a function of this thing. Yeah, that's perfect. Had a funny angle there in the back. So it's going to be 1, 2, 3, 4, 5 more. So the actual rivet pitch. And just a hair under the line, actually this last inch. Yeah. So pretty good. I was looking for 1 inch rivet pitch, and that's what I have here. So I'm going to drill it with number 40. Drill it. Now it's time to drill this out with number 30. Keep those together. Next, go get number 30 drill. Number 30 holes, use top holes to get those. So we're going to get. I'm preparing machine countersink for countersinking. I have a rivet, which is going to be hard to see. I'm going to be using it to double check my countersinking depth. use the top hole. Alright, so maybe just a hair shallow. So I will loosen this color. Turn it 2 clicks deeper. Tighten the color and recheck. Maybe too much, maybe not. So I marked the location of the first one here. So we're in the space that in any other vehicle would be called the cab, but of course on a Land Rover, especially a short wheelbase like this, it's just a space between the bulkhead and the front part of the rear bed. And I found something interesting here. This rear component is from a Santana Land Rover. It was made in Spain out of combination of parts that were made in Spain by the Santana company and also genuine Land Rover parts. This is a replacement Land Rover seat box piece that we have to rivet next to the seat box that I've been working on the bench, and it fits right here, and it has these holes that perfectly match the locations of the holes here, except that these holes are 1/4 inch and these holes are 5/16, and I'm holding a 5/16 transfer punch, which I'm using as a pin gauge here. And this 5/16 transfer punch actually vertically slightly loosen these holes, and they do tend to ovalize from years of use in soft aluminum. But in this hole, for example, it's pretty tight. So I will not be able to use 1/4 UNF bolts that would have been in this location in an English Land Rover. But the wonderful thing is that the holes match perfectly. So what I have to do is obtain 5/16 fine thread hardware for this location and drill out this flange to 5/16 from a 1/4. To elaborate slightly further on this, this is the hardware for attaching the seat base, or as I call it, seat box, to the rear body, which is of course this. I bought a complete set of Land Rover hardware from a Land Rover hardware business in Bolton, England, that will sell you every single fastener on your restoration. It'll be brand new and it'll come in a baggie like this. And so, like many fasteners on an antique Land Rover, this has a UNF thread. So this is a 1/4 inch fine thread bolt, which fits very nicely through this replacement seat box component, but will be way too loose in the 5/16 hole, of this Santana truck bed. I'm going to bring in the rest of the seat box assembly and see what we have in terms of fit. The sides of the seat box are attached to the door sills, while the angled piece, which makes the back top, is attached to the truck bed. So I'm going to drill and cleco them with the holes lined up, so that after final assembly, when I bring the box in, the holes that attach to the different components of the rear bed are going to be all lined up. So just drilling and clecoing in place so that when it's all riveted together, it will all fit the truck. All right, the box is back on the bench, seemingly. We would be ready to fit this top on the box, but not so fast. There's a depression back here which accommodates the thickness of this flange, of this angle in the back. And if only it stayed at this level, this would be fine, but there's a joggle right here. There's a joggle right here. And this center section is higher. And actually, as you can see here, perfectly even. So this would be a butt joint. And in this aircraft style aluminum fabrication, there are no butt joints. We're not going to be stitch welding it with MIG like we probably would if this was a steel unit. So this is going to need a doubler. Be sure to join me in part 2 for rivet banging action and conclusion of the seat box construction.